So today we'll be talking about our logarithmic properties. In our last set of notes, we talked about logarithms and exponentials and kind of their graphs. And then also before that, we talked about switching back and forth between the two of them. Today we're going to go over some of our properties that we have with them. So the first property that we have is called the change of base formula. This formula allows us to take any logarithm and change it to any base that we would want. So in our first example, it says base b, which means that I could make it a base of 2 or 4 or whatever base that we wanted. More commonly, though, what we're going to do is we're going to want to change it to a base of 10 or a base of e. So remember that our base 10 is our common log, and our base of e is our natural log. So the way that this works is we have log base a of x. That's going to equal log of x divided by log of a. Now we don't have a base on those logs on the right hand side, but remember that if there's not a base, then it's an understood base of 10. And the next one, we have log base a of x equals the natural log of x divided by the natural log of a. So both of those have a base of e. So let's go ahead and look at some examples. So it says use the change of base formula with both common and natural logs. So like I said, we can change this to any base that we want, but most of the time we're going to use our common log or our natural log. So for our common log, remember it's a base of 10, but because we don't have to write it, it's just going to be log, and then our number that's inside of the logarithm is what goes on top, divided by log, and then our base is what goes on bottom. So we would have log of 25 divided by log of 4. And our next one, we would do the same thing, except we have log of 12 divided by log of 2. Now remember, we can do the same thing with our natural log. Again, the 25 is going to go on top, and then on bottom we would have the natural log of 4. And on our second example, we have the natural log of 12 divided by the natural log of 2. Now, one of the biggest places that this can come into handy is if you're using a scientific calculator. Many times it won't have a button that allows you to put in different types of bases. So what you can do instead, if you're trying to find a decimal approximation, is if I can't plug in, say, log base 4 of 25, you could plug in log of 25 divided by log of 4, because your calculator will still have a log button. It's just a base of 10, and so you need to be able to convert any of your answers to a base of 10 in order to get that decimal approximation. Alright, so we also have a few more properties. We have our product property that tells us that if we have two things that are being multiplied on the inside, we can actually break that apart into two separate logarithms using addition. Likewise, we have a quotient property that allows us to break division up into subtraction, and we have a power property that allows us to bring a power inside of a logarithm to the front of the logarithm. Now, these properties should look kind of familiar. They're very similar to some of our exponent properties. So remember, when we multiply two things that have the same base, we add our exponents. When we divide two things that have the same base, we're going to subtract our exponents. And when we raise a power to another power, we multiply. And so that's where we get these properties from, are by our exponent properties. And in your book, there are some proofs on how we get these properties, so you can look at those if you want. I'm not going to make you write out the proofs or anything like that, but if you just wanted to know where these proofs come from, you could look in your book to see those proofs. So let's go ahead and start looking at some examples. So our first example says, write each logarithm in terms of the natural log of 2 and the natural log of 3. So what that's saying is, I want to use some of my properties either with multiplication, division, or with powers, and then switch that to our natural logs of 2 and 3. So on example A, I have the natural log of 6. So they give me the natural log of 2 and the natural log of 3. So I want to think, okay, what can I do to 6 to rewrite it as 2's and 3's? Hopefully we can think, okay, well, 6 is the same thing as 2 times 3. And then, because we have multiplication on the inside, we can use our product property to say that this would be the natural log of 2 plus the natural log of 3. Now, part B is a little bit different. So I have the natural log of 2 over 27. Well, I already have a division inside of my natural log, so I can go ahead and break this apart using subtraction. But I'm still not quite done because 27 is not a natural log of 2 or a natural log of 3. So again, we want to think about, okay, what can we rewrite 27 as? Well, hopefully we can remember that 27 is the same thing as 3 to the third. So we could rewrite this as the natural log of 3 to the third. And then using our power property, we can bring that 3 to the front of our natural log. And so natural log of 2 minus 3 natural log of 3 would be our final answer. All right, next up it asks us, find the exact value of each expression without using a calculator. Now, obviously, I know that we all have access to calculators, and so a lot of times we can just plug things in and we can get a value. However, there will be some instances, like when we have variables inside of our logarithms, or when things don't reduce, that we need to be able to rewrite them in an exact form. And this is just us practicing those. So obviously, all of these can be plugged into our calculator, and we could just do it that way. However, I want us to practice using our logarithmic property. So notice on part A, we have log base 5 of the third root of 5. Now, before we go ahead and get started, there is one important thing that we need to kind of look over. So remember that for our logarithms, remember that logarithms equal exponents. So let's say if I have log base b of b to the x power. Now, notice if I wanted to evaluate this, let's say we set this equal to y or some other exponent. So in order to evaluate this, we would say, okay, my base is b, logarithms equal exponents, so y would be my exponent, and then that's going to equal whatever's on the inside of my logarithm. Well, now notice, using our exponent properties, we know that since those are the same thing, y is going to have to equal x. So what that means is any time that I have a base and I have something that's the same base on the inside raised to an exponent, it's just going to equal that exponent. And that's going to work no matter what our base is. Now, that's not technically one of our properties because we can use that by evaluating. However, it is going to come in handy when we start trying to simplify things. So notice here, we could rewrite this as 5 to the 1/3. And then we could do this one of two ways. We could either use that little property that I just showed us and just say that this is 1/3, or if we brought that 1/3 to the front using our power property, then we have log base 5 of 5. Well, 5 is to the first power, so log base 5 of 5 is just going to be 1, and then 1/3 times 1 is just 1/3. Either way, we get 1/3. So then on part B, notice that we have the natural log of e to the 6th minus the natural log of e squared. Again, using that exponent property, I'm going to bring my 6 and my 2 to the front. Now this one's a little bit trickier just because we can't see that my base of my natural log is the same as what's on the inside, but remember that when I have a natural log, it's an understood base of e. So we know that natural log of e just equals 1. So we have 6 minus 2, which gives us 4. Now, if you kind of thought about that a different way, or wanted to approach it a different way, that's fine too. So notice that we could have instead used our division property, because my natural logs have the same base, so I can combine them to be 1 logarithm. So I have e to the 6th divided by e squared. So that would give me the natural log of e to the 4th. Again, using our power property, then we know that the natural log of e is 1, so we again get 4. So in some of these, there's going to be multiple ways that you can get to the same answer, depending on which property you use or which one you use first. But as long as you're using correct mathematical steps and you're showing me your steps, it doesn't matter which one you decide to use. Now, sometimes we're going to want to either expand or condense a given logarithmic expression. So in this example, we're going to be expanding the given logarithm basically as far as we can go. So we have log base 4 of 5x to the 3rd y. So notice that all three of those are being multiplied. So we can break that apart into 3 separate logarithms. And it is important that we break it into 3 separate logarithms. A lot of people will forget about that 5 and just want to leave it with one of the variables. But because it's still being multiplied, we need to expand it to where it is its own logarithm. Now, notice we still have an exponent on one of our logarithms, so we can use our exponent property. So I'm going to bring that 3 to the front. And then that would be my final answer. So then let's look at part B. It's got a little bit more going on with it. But just because it looks a little bit more complicated doesn't necessarily mean that it's going to be super hard. We still want to approach it the same way, just do one step at a time. So our first thing that we should notice is that we have division. So remember that we can separate anything with division using subtraction. So we would have minus the natural log of 7. Then hopefully we also recall that we can rewrite a square root as a 1/2 power. And then we can bring that 1/2 to the front. And so we would have 1/2 natural log of 3x minus 5 minus the natural log of 7. Now be careful, because we can only separate things when they are being multiplied or divided on the inside. So notice that we have a 3x minus 5. So there's no way for us to distribute that natural log or do any of our other properties, because we don't have a subtraction property. So that's as simple as it can be. So just be careful with that, because a lot of people want to try and distribute that natural log and still try and separate it out with subtraction. Now, likewise, we can go the opposite direction. Sometimes we'll be given something that's in expanded form and we need to condense it. So here we have 1/2 log of x plus 3 log of x plus 1. So we have numbers in the front. So our first thing that we want to do is rewrite those as powers. And then notice that we have two logarithms that are separated by addition. And just the same way that we can use our multiplication or product property to expand things that are multiplication to be addition, we can go the opposite direction as well. If I have addition, we can condense those to be two things that are being multiplied together on the inside of one logarithm. Now then, the last thing that I would probably do is just rewrite that as the square root of x. And so that would be our final answer. So on our next example, notice again we have a number to the front, so that needs to become an exponent. And then we have subtraction, so that's this time going to need to become division. So I would have x plus 2 quantity squared divided by x. And when we combine them to be one logarithm. So I don't have like two logarithms now. The logarithm itself doesn't go away. I'm still taking the natural log of it. I've just combined them to be one logarithm now instead. So now let's look at our last example. Now again, remember that we can approach this a couple different ways. We could go ahead and distribute that 1/3 to everything if we wanted to. What I'm going to do is go ahead and try and simplify the inside first and then take care of that 1/3 next. But again, as long as you're using correct steps, it's not wrong to do it either way. So we do have addition there. So we know that our addition can become multiplication inside of a one logarithm. And then because we have that 1/3 to the front, it would become an exponent. But remember that an exponent of 1/3 is going to be the same thing as the third root of all of that stuff. So that would be our final answer. Log base 2 of the third root of x times x plus 1. So those are all of our logarithmic properties. Hopefully now we can use them to help us simplify and eventually solve some of our logarithmic